Good evening, everyone. Thank you for sticking around this late in the evening on a Saturday after biryani is over and the free bags and t-shirts have been given. And basically, biryani is, I thought, would be the end of the conference. But it's amazing to see that so many people are sticking around. I think that really goes to show that the organizers are doing a great job. My name is Ram. I'm here to talk about Kubernetes and platforms. There's very little time in which I have to speak a lot. So I'm going to try and keep it as fast as I can. In the beginning, there were mainframes. Software engineers were very happy. Every time they wanted to write an application, they wrote an application, they deployed it. They take a LAN wire to the mainframe server room, plug it in, deploy it. Life was so cool. And then somebody somewhere decided, hey, let's modernize everything. And then they brought in this new concept of infrastructure and applications and all of these things in the middle that can all work. And then they further improved it by using concepts like virtual machines and containers and things like that. And today, we're all sold on this concept of a container, and an application doesn't just mean a little bit of programs that you write. Instead, the application stack itself is extremely deep. And then they introduced this concept known as CI/CD, saying that, that we're going to make deploying applications more reliable and everything. But what they didn't realize is CI/CD is a bunch of different applications together. And so it just multiplied this concept of having so many different stacks that people have to manage. And then along the way, we discovered this cool tool called Kubernetes. And Kubernetes was meant to solve everything, right? So the world was supposed to be green again and all of that. But please remember, there's a very small part of the stack that Kubernetes is meant to be used for. So it takes care of, it's an algorithm that takes care of container scheduling, does a little bit of process healing so your applications are reliable, and decides where to put your container so that resources are used best. Now, everybody here has probably done a Kubernetes-based deployment. I'm just going to kick this off to showcase a couple of things. So how do you decide that Kubernetes is sufficient for you as an organization? Maybe a lot of you didn't. Maybe Google using Kubernetes was good enough for people. And it's much more complicated than that. I hate to say this at a Kubernetes community day, but if you're really struggling with Kubernetes and if you're really figuring out how best to provision your resources in terms of engineering capital that you have and things like that, Kubernetes probably isn't for you. And that's not a bad thing. Before you kick me out and not invite me to the next KCD event, please know that there are teams out there for whom Kubernetes is not a great fit. But if Kubernetes is a great fit for you, then the rest of this talk is basically going to build in stages towards an understanding of how it can be fit into your team best and how you can harness the power of Kubernetes without driving your engineers crazy. So this is a quick demo of, this is a demo of how to cloud natively build your containers. So everybody uses Docker build here? Yes, no, maybe, show of hands. Let's do some exercise. It's 4:30. I know it's not a great time to be looking at terminals and architecture diagrams, but anybody heard of cloud native build packs? Yes, no. Are people using them? Yes, no. Using them in production? Yes, no. Okay, one person, thank you. You're the saving grace of my talk today. So I'm just demonstrating a quick way to do cloud native build packs based development. The reason I love cloud native build packs is it doesn't care what your language or framework is. It generates an OCI based container without having to use a Docker file. It's extremely useful when you're trying to design a homogeneous build experience for all the different people in the organization. And I mean those dinosaur uncles and aunties who like to use Java to the new hipsters you hired out of college who like to use TypeScript, and everybody in between. So Pack is a wonderful way for you to try what a build experience can be like. And build packs can help you provide that uniform build experience for all of these different people. I've seen it used in AI ML based workflows. I've seen it used in regular sort of builds and things like that. I've seen it used for Java and PHP and all of these things. And so here, it's just deploying to a kind cluster, which I can show works, hopefully. So you'll see here that there's an app. I guess I am one of those Java uncles, but there's an app that was built using build packs. It's deployed to a Kubernetes cluster. So build packs is not something that I'm making up, and it's actually real. So if that demo has you going, oh my pod, I like it, I highly encourage you to go back home, try build packs. This is a very famous tweet. No talk that has platform engineering in its title is allowed to be, exist without this tweet. But more than that, I like this one. So this was Aparna Subramanian, who was CNCF co-chair, probably still is. But on the CNCF keynote stage, like on the KubeCon keynote stage, she had the gall to give a 1-star review to Kubernetes for simplicity. And what that did was, ever since that happened, there have been so many different teams who are building platform products, and it's all the same. So if you read through these screenshots of their websites, sorry, I have to really rush, but it's all the exact same thing. Make it faster, make it resilient, make your teams better, as if they were not good enough and you didn't know who you were hiring. So it's very hard to ignore platforms at this stage for Kubernetes, and where all of these platform projects differ is where you want your teams to start. So one of what I had showcased was this base camp sort of thing, where you want your teams to go in and build everything themselves, and build packs are great for that, etc. But let's move up a little, and let's talk about Dapper. Before I do that, I will kick off a demo script, and yeah, that will do its job until we talk a little bit about Dapper. Now, Dapper is a CNCF project. Again, fair warning, everything I showcase during today's demo will be open source, so you can go home and try it and verify if what I say on stage is true or not. Now, Dapper is a project that was basically created to simplify certain things that developers repeat when they do things. So it doesn't claim to be a platform project by itself, but if you find yourself in the business of application development and you're constantly following patterns in terms of you're building PubSub, for example, or you're building something having to do with observability, or you have some other stateful applications that you're deploying, Dapper gives you SDKs for all language families that you can integrate with, make use of Dapper tools, and simplify life for your developers in specific areas that they're working on. Again, one warning that you have to kind of know is everything that you see will sort of be opinionated and say, hey, this is how Dapper likes to do things, and that is how Dapper doesn't like to do things, etc. But so you will notice here that Dapper will start installing itself onto a Kubernetes cluster. So in this case, I'm just going to quit very quickly, restart it. And so what Dapper will do is it will install a bunch of operators. If it's not visible at the back, don't worry, it's recorded. You can view it at your leisure. But it's going to inject a bunch of pods, and these pods will allow all Dapper-based applications to be deployed as sidecars. Now, hopefully people here know what sidecars are. If you don't, sidecars are pods that are injected into a Kubernetes runtime so that you can make use of them as if they were always there. All right. So what Dapper is doing here is it's throwing in a Redis service, which is the state store and the data store that we had seen earlier. And then it's going to create one Node application and one Python application, which are just sample apps, throw away. But what it's going to do is send messages back and forth between these two. And it's all in one demo, okay? So if you look at the logs here, which is the fundamental source of truth for any good engineer, you'll notice that there's a state store, there's a pub sub, and these components are getting added as sidecars because there's a Dapper running inside your Kubernetes cluster. So the architecture that Dapper follows is too complex for 5 o'clock, I know. So what it basically does is it has your pod here, and it can create these kinds of components that you can use as SDKs inside your applications as you develop them. So it will save your developers a ton of time. That's really what it does. So once all of this gets set up, what will basically happen is this Node app will send a few messages. The Python app will receive those messages. Right now, I think, so the Node app is waiting for data to come to it. The Python app is not ready yet, so it's not sending anything. So we will either wait or move on, and I'm thinking moving on because it's taking much longer on the 5th floor than it took on the 7th floor, I'll tell you that much. But anyhow, this demo didn't have you going, oh my pod, so I won't do anything. The next piece of technology I wanted to showcase was this thing known as crossplane. And I've heard like a bunch of different crossplane conversations since morning. Hopefully the crossplane demo is faster than the Dapper demo. But if you're not using crossplane yet, your spread probably looks like this. You have like a bunch of different applications talking to a bunch of other applications somewhere on the stack, and then you have like different pieces of infrastructure that you're using to connect to all of these things, and maybe those pieces of infrastructure don't necessarily talk to each other. And Crossplane came up with this idea, or the Crossplane community came up with this idea of taking CRDs, or custom resource definitions, and adding an abstraction over that called composite resource definition. So what Crossplane says is basically, use me in order to connect with any API out there in a Kubernetes native way. So allow Kubernetes to become the central piece of your infrastructure, along with a few Crossplane things that are added on top of it. And these Crossplane CRDs will process anything that you give it, as long as there's an API out there to consume it. Does that make sense? Anybody have any questions? Again, meet me afterwards. But anything that has an API, Crossplane can connect to it and do something. And what I'm attempting to do here is to create a namespace on the API that I have, on the Kubernetes cluster that I have. So it's getting set up. And so what you can see here is a bunch of different cross-plane pods that are available on the Kubernetes cluster that I have, and it will accept any incoming request in the form of a YAML file. I don't know if people love YAML or hate YAML here. I don't know. But you can write YAMLs that basically dictate what you want the end state of anything to be. So if you have AWS infrastructure, for example, and you want that set up, so you can write a crossplane definition that will basically go and create an AWS infrastructure out there for you. So now, if I look at all the namespaces here, so this is a namespace that was custom made by writing a piece of YAML file. You could argue that you could do the same thing with kubectl and things like that, but the idea is Crossplane can connect to any API-based interface and do like a bunch of different things for you. So I really love Crossplane in that regard. And if this demo made you go, oh, my pod, you can go and check out Crossplane. Again, it's fully open source. Try it out. If you have any endpoints out there that you can benefit from connecting to a Kubernetes cluster and making use of. Crossplane is a wonderful thing. And Dapper and Crossplane are not mutually exclusive from each other. They're basically very good at working with each other. There's a few projects that demonstrate how you can use Dapper in conjunction with Crossplane, and I highly recommend those. Now, my last set of slides are about platform tools that really abstract a lot more in the level. And Radius is a great example of that, and so is Cloud Foundry Koryphi. Now, I know a lot of people here might know Cloud Foundry and have had mixed experiences with it. I know some of you here might have had good experiences with it. I highly recommend checking out Cloud Foundry Koryphi as a project. It really abstracts, thank you. It really abstracts Kubernetes in a way that can make it much more useful to developers. And I'm going to quickly demonstrate, without going into installation and things like that, just quickly demonstrate what Koryphi looks like, because I have that here. So yeah, this is the entire sort of Koryphi system. So it packs a bunch of different gateways, a bunch of different API controllers, a bunch of different things, and it packages Cert Manager and everything that a developer basically needs in order to put their applications in production. So I'll quickly demonstrate what deployment looks like. So Koryphi takes this familiar pattern of what is known as CF push, and you give an app name, if I can spell. And then what it will do is it will make use of the build packs experience that we saw from before. It will make use of a sudo injection kind of thing in order to take this and deploy it to the container. It will also create an ingress around it. If you have more than one instance of the app requested, it will create a load balancer. And so it will do everything that a developer needs to get their app from their laptop onto a functional Kubernetes cluster. Now, this can also save you a lot of time in making your CI/CD much more easier and much more functional. And okay, as with all demos, for some reason it crashed. Again, this did work on the 7th floor. I'm not lying. But what this basically demonstrates is there's a way to get code onto clusters, and it doesn't have to be hard, and your teams can really go, do it. If this demo had you going, oh my pod, I highly recommend checking out Project Koryphi. Again, it's an open source project. For those who are out there looking for ways to get onto open source, the community is very inviting, so do try it out. Any feedback is much appreciated. Now, going back to this, again, it's about what you want to abstract, what you want to expose for your developers, and how to simplify things. This is a summary of the whole talk that happened. If you're curious about what kind of abstractions we're dealing with and things like that, that's what we demonstrated today. Sorry for going over time. Sorry for keeping you all late. Thank you, organizers, for having me. It was a pleasure. Please connect with me on social media. Don't be shy. Say hi. I'll incentivize one more thing. If you have any questions and want to chat with me about Cloud Foundry, Koryphi, platforms, whatever, I'm more than happy to do so. I have a bunch of stickers. I'll have them somewhere where the organizers permit me and sit around. But very happy to chat with folks and take this conversation forward. Thank you for coming and attending the talk.
Thank you. It was truly Oh My Pod session. So thanks once again. Yeah, please be.